Hello, and welcome back to Math Extra. For those of you who don't know me, my name is Mr. O'Neill. I'm a math teacher at Piedmont, IB Middle School here in Charlotte. And to all my 8th graders, here we go. Let's get ready to do the math on Math Extra. Eighth graders, I'm excited about today's lesson. It's on the Pythagorean theorem. Quick personal story. So I never knew why a squared plus b squared equals c squared until I got to college and one of my professors asked me, so why is a squared plus b squared equal to c squared? I mean, all of us, there's about 18 of us in the room, and we looked at each other and none of us could tell him why. So I'm excited to teach you why a squared plus b squared is actually equal to c squared. So let's get into the lesson for today. So here we have the Pythagorean theorem that is actually named after the mathematician Pythagoras. So he was really confident because he named the Pythagorean theorem after himself. So let's talk about what Pythagoras actually discovered. Now I'm gonna read this twice because when you read it the first time, it may not make sense. So it says, for any right triangle, the sum of the squares of the sides A and B add to give you the square of side C. So I'm gonna say that one more time because I really want y'all to get this, okay? So for any right triangle, so this only works for right triangles. You see this right angle symbol? Okay, for any right triangle, the sum of the squares of the sides A and B, so if I take the sum of the squares of the sides A and B and add them together, they will give me the square of side C. Now students, this is what I love about this theorem because it's visual and it makes sense. All I needed was for a math teacher to tell me why, and I wouldn't sit in class looking crazy because I couldn't show the teacher this theorem. But you will never have to struggle the way I struggle. So let's look here. So if we're saying the sum of the squares of side A and B, if I take this side A right here and I square it, notice if I take side A, change my color real quick. If I take side A and I square it, the visual is a square. A times A is a square, okay? And if I take the side B, which is this side right here, and I square it, B times B gives me B squared. So again, if I take this side C and square it means that we're multiplying it by itself. If we square that, C times C is going to actually give us C squared. So this rather says that A squared, the side A squared, plus B, the side B squared, equals C squared, the side C squared. And the most important thing, y'all, that if I square C, square A, and square B, it makes a what? A square. So let's look back at the theorem. So if I square side A right here, it makes this square. What is this square? This square is a 3 by 3. What's 3 times 3 or 3 squared? 9. If I square side B, what does it visually make? A square. 4 by 4 is 16. And now if I square side C, that's a 5 by 5 square. So we have the 9 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have the 16 here. And so if I add the 9 and the 16 together, it's going to give me 25. Now, I know that makes sense. A squared makes a square. B squared makes a square. C squared makes a square. So the square of A, visually you see a square, plus the square of B, visually you see a square, equals the square of C. Visually you see a square. It makes sense. All someone had to do was to show me this proof. Okay? So let's move on and see more about the right triangle. So in a right triangle, there are different parts of the right triangle. So the legs are actually the sides that form the right angle. So these are the shorter sides. It does not matter which side is A or B. So when I look at this, the sides of a right triangle, it doesn't matter which side is A or B. I just need to know that sides A and B are the legs. Now, when I teach this, I usually say, like, we can make A the shorter leg and B the longer leg if we wanted to, but it really doesn't matter which side is A or B. Now, let's look at the hypotenuse. The hypotenuse is the side across from the right angle. It's the longest side. So when I look at this side here, C is always across from the right angle. Everything that concerns the Pythagorean theorem is really focused on the hypotenuse, because the legs are A and B, but the C is the longest side and it's across from the right angle. Sometimes students don't know where it's at, because I used to teach it back in the day that it was the diagonal side. But when you turn the right triangle, you might not have that diagonal side again. So please remember that the hypotenuse is across from the right angle and it's the longest side. So let's identify A, B, and C from the right triangles below. So here I have identified that this side is A. If I said this was my shorter leg, my longer leg, A, B, and C. The reason why I call this side C, because it's across from the right angle. Again, if I let my A be my shorter leg, that's my shorter leg. B is my longer leg. How do I know this side is C? It's across from the right angle. And again, no matter how I turn my right triangle, C will always be across from the right angle. So A and B are legs. They are the shorter sides. C is across from the right triangle, so I should never be confused about, oh, what's C? C is always across from the right triangle. Now, sometimes students say, well, this side looks longer. Follow the rule. C is across from the right triangle. All right, so now let's use the Pythagorean theorem. So here we have the Pythagorean theorem is A squared plus B squared is equal to C squared, and we know why, which is amazing, okay? So if we have A squared plus B squared is equal to C squared, what is this missing side? Well, it looks like it's across from the right angle. Students, please don't make the mistake of using the wrong formula of putting A where B is supposed to be and C where A is supposed to be. When you identify the side across from the right angle, you know that's your C. And you know now that the A and B really doesn't matter when it comes to the formula. Okay, so we have to solve for C. So I said my shorter leg is A, my longer leg is B. They really don't matter, but you know that's the way Mr. O'Neill teaches it. So we have A squared is 6 squared plus B is 8. 8 squared is equal to what we don't know is C squared, though that is X. I like to use the variables that are given in our problem. 6 squared is 36, not 6 times 2. I know y'all taught y'all better. 8 squared is 64, not 8 times 2 is equal to C squared. So we have 36 plus 64, that's going to give me 100. So we get C squared is equal to 100. Now, if you're like my kids, no matter where you're at, when we get to this whole, hey, what am I supposed to do now to figure out what C is? I want to know the side C. Remember, C squared is the square. We don't want to know the square. We want to know what the side is. So to undo something's being squared, we take the square root. We do not divide by 2. We do not divide by 2. We are asking ourselves, what number was squared to give me c squared? And the square root actually asked that question. What number was squared to give me the number inside of the radical? So we take the square root. So we have c is equal to 10. Now, technically, this could be positive or negative 10, but because we're talking about side lengths, we only use the positive root, okay? Now, let's look at the next one. So we're looking at, if I said, notice my c, hey, I got my c this time. All right, well, it looks like this one is shorter than this one, so I'm gonna let that be A, I'm gonna let that be B. Do you understand why it's important to identify C? Because I want to make sure that I don't put that in the place of A. So identify C first and then let the legs fall where they may. Okay, let's look at the problem. So if I let that be A, so I have A squared plus B squared is equal to C squared. I'm going to get used to writing the equation. A squared is what we don't know, plus 15 squared is what we do know, and 25 squared. So now I have A squared plus 15 squared is 225. 25 squared is 625. So this looks a little different. So I want to get to A. And so this is an equation, everyone. It's almost like a two-step equation, okay? So if I want to get A squared alone, what would I do? Let's look at the problem. So I would get this away. So 225 was added to some number squared to give me 625. So if I take that 225 away, I will end with that number being squared, which was 400. And so how do I undo a number squared? We don't divide by 2. That's what we don't do. We take the square root. I know y'all know better. Take the square root. So what is the square root of 400? Well, that number is 20. Now, Mr. O'Neill did something that he tells his students never to do, is to forget your units. That's 10 inches. That is 20 yards. Okay? So what I'm about to do, don't tell your teachers because I'm about to show you something. So I'm going to show you some shortcuts. Since we know the math behind this, I love efficiency. So we know that a square plus B squared gives you C squared. We know that, but I'm going to show you some more efficient ways to getting to C. So watch this. So Pythagorean theorem shortcuts. So we know that A squared plus B squared equals C squared. Look at our image over here, y'all. Look at this. We know this. We know why. Yes, we know why. Okay, so if I want to know what C squared is equal to A squared plus B squared. And I know what you're thinking, Mr. O'Neill, you didn't do much. Wait on me, okay? So I like to solve problems from left to right. So anytime I see the Pythagorean theorem, it's just a habit that I love to do. I just love to solve problems from left to right. So watch me, okay? So if C squared is equal to A squared plus B squared, what is A squared? Well, let's look back up here. So in the equation A squared plus B squared is equal to C squared, what do I have to do to get A alone? We've done that in the last problem. We had to subtract 225 from both sides. So that's what we're doing now. We're going to subtract B squared. Watch this. So we can subtract B squared from both sides, and that's going to give me A squared is equal to C squared minus B squared. So A squared is equal to C squared minus B squared. And in the same right, what is B squared equal to? What is B squared equal to? It's a leg. So if I need to find that leg, it's going to be equal to this. Watch. C squared minus A squared. Now I know you're thinking, Like, Mr. O'Neill, that's cool. You're telling me that, you know, instead of subtracting and in the problem, I can go ahead and subtract early. That's great. So I simplified your life just a little bit. Now watch this magic, okay? Watch this. So if I want to just find out C, I'm gonna go back to the problem and show you what we've been doing the entire time. Again, this is a secret. I haven't even showed my students this, okay? So in the end, this number and this number represents my a squared and my b squared. What would we have to do at the end? We took the square root. Over here, this number 400 represented the subtraction of c squared and b squared. And what do we do at the end? We took the square root. So this is the deal. What would I have to do to find any side? At the end, take the square root. Now you're gonna love me for this. Watch this. So in any problem, if I know that c squared is equal to a squared plus b squared, well, c is just simply equal to the square root of a squared plus b squared. Now y'all know you got this. All right. So c squared minus b squared, if I just take the square root of that, that is going to give me a. And then b is going to be equal to the square root of c squared minus a squared. Now I know what you're thinking. Why you didn't show me this in the beginning? We never show y'all this in the beginning because you'll just be like, I don't care about the math, I just care about the answer. We want you to care about the math. So now that you know the math and you can tell and show anyone why a squared plus b squared is equal to c squared, you can now easily solve for c, you can solve for a, you can solve for b using our shortcuts. So that is going to be the end of our 8th grade lesson on the Pythagorean theorem. I know you know why a squared plus b squared is equal to c squared, and you never have to struggle like I did in explaining it. Hey, I got to admit, I miss being in the classroom. And I miss teaching math to my students. But there is one way I can still connect with students, and that's when you send in a Math Extra video question. So let's check out this video.
Hey, my name is Aiden, and I have a question. Why do teachers always say that C has to be the longest side of the right triangle? Why can't it be A or B?
Aiden, I'm so glad you asked that question because I honestly say C is the longest side. And I have to admit, I've never showed my students why. So I'm thankful that you're making me a better teacher. Okay, so let's look at this. So what if you had the sides of a triangle? Okay, we're gonna have to do that over. It did not do what I wanted to do. What I'm pressing, hold on, let me, okay. There we go. I hit the wrong button. So what if you had the sides of a triangle and we had to make a right triangle? So that's the leg, And what if I made the hypotenuse the same size? Okay, all right, so I have the leg, this leg here, and the hypotenuse the same size. So watch when I try to make this right triangle. So I'm going to do this. I'm going to try to make this right triangle with C being the same size of one of the legs. Okay, watch me. So here I know, well, hey, I have to slant this. So I'm gonna try to manipulate this the best way I know how. I'll bring that over there. I'll take this out right here. Man, what's the issue I'm having? If the side is the same, if this side right here is the same as this side, I'm having an issue, y'all. Watch this. This is the issue I'm having. If this is, say for instance, I said in the last video that A is the smaller leg, so I'll make that be A, and I'll make this be B, and I'm calling this C. And if C is the same size as B, do I have a triangle, y'all? No. And more importantly, do I have a right triangle? Now I can turn watch this. So I could try to turn A, the side A, in a way that, hey, go meet up with C. And when I do that, what happens to my angle? What's going on right here? Do we have a right triangle? We don't. We do not have a right triangle. So watch one more time. So I must, if I want to keep my dimensions of my right triangle, and I bring this down so I make my right angle, I have to do this to C. I have to extend C in order to meet the side A. So I've never been asked this, and I'm grateful that you asked me. Now I feel like I need to go back and reteach this to my kids, because sometimes as math teachers, we say stuff, but we're trying to raise you all to be thinkers. So now I can't have a right triangle if C is not the longest side. Thank you so much, Aiden, for sending this question. You made me a better teacher today. 8th graders, you know what time it is. It's time for the Math Extra Extra Credit. Show what you know about today's topic and answer this question here. Take a look at this rectangular prism. Try to find the length of side D, but remember, use right triangles to help you find the length of side D. That's our 8th grade lesson for the show. And that's it for this episode of Math Extra. I know that wasn't tough for you. Here's what I want you to know. School is in session. This is not summer vacation. Teaching and learning is happening, and we need you to stay engaged, and we want you to step up now so that you don't have to catch up later. I'm Mr. O'Neill, and on behalf of the entire Math Extra team, be safe and be smart, and we'll see you next time on Math Extra.